In this lesson, I'm going to look at indices. So let's look at notation, what you always come across in indices. So a short form of writing a times a times a is equal to a raised to 3. So a is known as subscript, and 3 that's written on top of a is known as superscript. But in mathematics, the a is known as base, and the 3 is called the power. So the number a is called the base, while the number 3 is the power or index or exponent. So you can use any of these 3 words to describe the number 3. They mean the same thing. So you could say 3 is the power, or 3 is the index, or 3 is the exponent. So a short form of writing a times a times a is a raised to power 3. The number a is called the base, while the number 3 is the power, index, or exponent. So let's move on to laws of indices. A raised to power 2 is written as a times a, or a raised to power 2 means that a multiplies it's going to be a repeated multiplication of a 2 times. So and a raised to power 3 implies that a multiplies itself repeatedly 3 times. So if a is 2 and any number is raised to, it tells you the number of times the multiplication is to be repeated. So maybe 2 raised to power 7 tells you that this base 2 is to be will multiply itself repeatedly 7 times. So the power tells you the number of times that a should multiply itself, or the number of times that 2, which is the base, should multiply itself. That's what indices mean. So if it is if it is 7 raised to 2, it means that the base 7 should multiply itself 2 times. That's what it implies. So take note of that. So a raised to power 2 is equal to a times a raised to power 3 is a times a. Now, what do we get when it is a raised to power 2 times a raised to power 3? This is where a lot of indices come in. So a raised to power 2 is a times a raised to power 3 is a times a. Altogether, we're going to have a raised to power 5. How do we come about this? Now, consider the relationship between the powers. 2 plus 3 is equal to 5. So in general, whenever a raised to m times a raised to n is equal to a m plus n. So whenever the bases are the same, but the index or the indices are different, it doesn't matter whether they are different or they are the same. But once the bases are the same, you simply add the powers together. That's the addition law of indices, or the multiplication law of indices. Once the bases are the same, the 2 bases are the same, irrespective of the exponents or indices, just add them up together. So a raised to m times a raised to n is equal to a m plus n. B, a raised to 5, you get is, that means the base should multiply itself repeatedly 5 times, and same applies to a raised to power 3. So what do you get when a raised to 5 divides a raised to 3? 8 raised to 5 and a raised to 3. And so here, if you cancel a, cancel this, a, cancel this, a, cancel this, you will be left with a times a, which is just 2. So that's from here, you get here equal to a times e, which is a raised to power 2. Now consider the relationship between the powers. 5 minus 3 equal to 2. So in general, a raised to n divided by a raised to n is equal to a raised to m minus n. So what this tells us is that whenever the bases are the same and you have to divide, or the operation is division, all you need to do is to subtract the indices. So you pick one of the base and then raise it to the value you get when you subtract one base, one power, one exponent from the other exponent. So a raised to subtract the second exponent from the first exponent. So subtract the second index from the second index. So that will give us a raised to m minus n. So minus, you carry out minus operation when it's division between two similar bases. And C, this is power. So a raised to 3, a times a, a raised to 3, or raised to power 2. So this, anytime a number is raised to power 2, like we have here, raised to any number, it tells you the number of times that base should multiply itself repeatedly. So now it is a raised to power 3 raised to 2. It tells you that A raised to power 3 should multiply itself repeatedly 2 times. So that would give you A raised to 3 times A raised to 3. So this is A raised to 3 and this is A raised to 3. All together, because of this multiplication, we have A raised to power 6. So observe the relationship between the powers. 3 times 2 is equal to 6. So in general, A raised to m raised to n, that gives us A raised to n. So 3 times 2 gives us A raised to 6. That's what it implies, because E, M, N. So where our n is 3 and 2 is n. So just multiply 3 times 2 will give you 6, A raised to power 6. Then 0 index. We know that A raised to m divided by A raised to n is equal to A raised to m over A raised to m, which if you are bringing the division sign, and that will give you 1, just like we did here. A raised to 5 divided by A raised to 3. This is division form. You cancel to get 1. So if A raised to m, say A raised to power 2 and A raised to power 2, this gives us A times A over A times A. A cancel. What would you have left? A divided by A is 1. A divided by A is 1. So 1 times 1, that will give us 1 here. Okay, also A raised to m divided by A raised to n is equal to A m minus m, which gives us A raised to 0. And in indices, any base raised to exponent 0 is equal to 1. So for 0 index is always equivalent to 1. So E, negative index, A raised to m times A raised to minus m is equal to A m plus bracket minus m, close the brackets. Why is there plus? Because of multiplication. When the bases are the same and your process multiplication, you add the indices together. So where this one is already negative, so plus times minus will give us minus. So m minus m will give you 0. So A raised to power 0, and of course A raised to power 0 will give you what? 1. So another way is that A raised to m, let me just say A raised to power 0 is equal to 1. And A raised to m times A raised to minus m is equal to 1. Why? So if you bring, okay, we've already done that part. So A raised to equal definitely, okay, this like this part here is exactly what I did here. This notation, you simplify this way, you get this final answer 1, and that's what I just put here as equal to 1. The another way to go about it is that A raised to m times A raised to minus m divided by A over m. A raised to m rather is equal to A raised to m minus m over A raised to m. So this gives us that m minus m is 0 because there's multiplication. It's supposed to add. When you add, plus times minus gives us minus. So you have m minus m, which gives us A raised to 0. And of course, A raised to 0 is equal to 1. So which gives us 1 over A raised to m, which is what you have here. In general, whenever you have negative index, A raised to minus m is equal to A is equal to 1 over A raised to m. Then fractional index. For fractional index, A raised to 1 over 2. This is a fractional power raised to power 2. So A raised to 1 over 2 is equal to A raised to 1 over 2 times 2. Just as we have here, multiply the powers together, 3 times 2 to give us 6. So 1 over 2 times 2, 1 over 2 times 2, 2 here 1, 2 here 1, so that's equal to 1. And so that's why you have A raised to power 1, and anything raised to power 1 is equal to the same base, which is A. Also, root A raised to power 2, root A raised to power 2 is equal to A. Root A is also the equivalent of A raised to 1 over 2, where this root is 1 over 2. So when it's raised to power 2, 1 times 2 is equal to 2. That's A raised to 2 over 2, 2 here 1, 2 here 1, and 1 divided by 1 is 1, and A raised to power 1 is equal to A. So you're going to have A back. So A raised to 1 over 2 is same thing as root A. That's it. It's actually that this root sign is same thing as 1 over 2 in fractional index. That's what it implies. So, and then A raised to 1 over 3 is equal to, for A raised to 1 over 3, 1 over 3 means A raised to 1 over 3. This 3, the denominator will give us the third root. So root A. So that's what it implies. If it's A raised to 1 over 4, 1 over 4, the 4, which is the denominator, will give us, in indices, is going to give us the fourth root of A. The fourth root of A is written as E1 over 4. So both of them are the same. If it's 1 over 5, that would give us the fifth root. It's 1 over 6, the sixth root. But if it is 2 over 7, let's say 2a raised to 2 over 7, the denominator of this going to give us the 7th root of a. Then this numerator will give us a power, a raised to power. So that's how we go about it. So a raised to 1 over 3 times 3, 3 times 1, 3, 3 divided by 3, 1. A raised to 1 will give us a, so that's why you have a here. And then 3 root a, remember a 1 over 3. Since 3 is the denominator, it's now give us the third root of e, then multiplied by the power, or raised to this power 3, raised to the power 3, which is also equal to e, because third root of e is still same thing as e 1 over 3, and then raised to this power 3. 3 times 1 will give us e 3 divided by 3, 3 here 1, 3 here 1, 1 divided by 1 is equal to 1, so that's e raised to 1, and e raised to 1 is equal to e. That's what you have here. Okay. So similarly, a raised to 1 over n multiplied by n will give you a, and this is the reason. So n, a raised to 1 over n is same thing as n root a, as the nth root of a. Then this n is what you have here. So if you simplify this, n times 1 will be n divided by n is 1, and that will give you a. Same thing here. By the time you convert this to this form and multiply n the power by 1 and divide by n, you're going to have a. So whether this or this will give you a. Then if it is a raised to m over n, that will give us a equal to a raised to 1 over n multiplied by m. Why? Because this m multiplied by 1, that gives us m over n here. So if you split it, you're going to have 1 over n, a raised to 1 over n times power m, and that will give us the nth root of a multiplied by m. That's by ourselves. Okay. And that's what I did here. 2 over a raised to 2 over 7. That will give us 7th root of a multiplied by 2. So these are the laws of indices. I'm going to also summarize them again for clearer understanding. Summary of the laws of indices. Well, number 1, I change the letters. X raised to power a times x raised to power b is equal to x raised to a plus b. Well, what you should notice that but x raised to a times y raised to b is not equal to x raised to a plus b. This means that for the law of indices to be applicable, the bases must be the same, or it must be alike, similar. When the bases are not alike, you can't apply the law, or the multiplication law of indices is not applicable in a case like this, because this is x, this is y, the bases are not the same, so you cannot add the indices. But when the bases are the same, the indices can be added following the law of multiplication of indices. So examples of simple application: 2 raised to 5 times 2 raised to 1 is equal to 3, 5 plus 1 is equal to 2 raised to power 6, but 2 raised to 5 times 2 raised to 1 is not equal to 3 raised to 5 plus 1. Why? The bases are not the same, so you cannot apply the law in this case. Same way, 7 raised to power 2 times 7 raised to power 2 is equal to 7 raised to 2 plus 2, which is 7 raised to power 4. But 7 raised to power 2 times 8 raised to power 2 is not equal to 7 raised to 2 plus 2, because the bases are not the same. So take note of that. 2, x raised to a divided by x raised to b is equal to x raised to a minus b, or x raised to a divided by x raised to b is still division. So since the bases are the same, you subtract the indices a minus b. So examples of simple application, if you have them here, these are the examples. Follow them through. Peculiarly, look at number 3. 3 raised to 4 divided by 3 raised to power 2. Since the bases are the same as division, you subtract the indices to get raised to power 2. Same way division, so either division presented as with this symbol or this line division, you do the same thing as long as the bases are the same base, the same base, the same base. Then you subtract the indices. Then 3, x raised to 0. Whenever a value is raised to power 0, the answer is 1. So examples of simple application is 2 raised to power 0 is 1, 10 raised to power 0 is 1, 1000 raised to power 0 is 1, 4 raised to power 2 raised to 0 is also 1. So regardless of how large or small the number is, if it is raised to power 0, the answer is always 1. Number 4, x raised to minus a is equal to 1 over x raised to a, and y over x raised to minus 1 is equal to x over y. So why is it so? Because from this rule, x raised to minus e is equal to 1 over xa. So y over x raised to minus 1 is equal to, what we're going to have is y minus 1 over x minus 1. And of course, y minus 1 means 1 over y is division divided by 1 over x. Remember from this rule, x raised to minus a is equal to 1 over x raised to a. So since our a is 1, so that's why we have y raised to 1, and y raised to 1 is y, x raised to 1 is x. So here you can have 1 over y. From fraction, whenever we have division of fractions, what we do is that we change the division sign to multiplication, and then for the next fraction be affected in the sense that the denominator would become the numerator and the numerator would become the denominator. So x over 1 will change. This will give us x over y, which is what we have here. So basically, whenever a fraction is raised to a negative power, it's going to reverse. The order of the fraction will be affected. The numerator will become the denominator and the denominator will become the numerator. Also, 1 over x raised to minus e will give us x over a. Why is it so? 1 over x raised to minus e is equal to, now minus 8 this will give us 1 over x, 1 over x, 1 over x, and this is equal to 1 divided by 1 over x, and of course it's equal to 1 times x over 1, and that's equal to 1 times x equals to x. X divided by 1 is equal to x. That is x. So, and well, in this case we have is raised to e. So if we represent 1 over x minus e, so that's 1 over x raised to power e. So here's e, and then there's e. So that's why it's x raised to power e here. And x raised to minus 1 is equal to 1 over x. So that's understood. Then y over x raised to minus e, like I explained here. This example, y over x raised to minus 1. When it's minus 1, it will be just x over y. But when it's y over x raised to minus e, x over y raised to e. So take note of that. So examples on simple application: 10 raised to minus 2 is equal to 1 over 10 raised to 2. 4 over 5 raised to minus 2. You change the order of the fraction. 5 over 4 raised to 2. Then 1 over 100 raised to minus 2 is equal to 100 over 1 raised to 2, which is equal to 100 raised to power 2y. 100 divided by 1 is something as 100. Then x, that's the fifth law. xa multiplied by b raised to power b, x raised to a raised to power b. So you simply multiply the exponents together. So x is equal to x a b. Examples on simple applications: 2 raised to power 3 times raised to power 2 is equal to 3 times 2. 2 raised to 3 times 2 is 2 raised to power 6. 5 raised to 2 raised to 2 equals 5 raised to 2 times 2 is equal to 5 raised to power 4. And then the sixth law: x raised to 1 over a is equal to a root x. So the denominator of the fractional power will form the root. That whatever this value is, that will be the root of x. So if it is 1, if it is 2, if it's 2, which is 1 over 2, it's going to be root x as the second root, but we don't write 2. Anything above 2, we're going to write the number after on top number here, then the square root sign, then the base inside the square root sign. So if it is 1 over 3x, that means the third root of x. If it is 1 over 4, but if it's 1 over 2, you don't write the 2, just write the square root sign. So that indicates that it's just the second root of the base. The examples on simple application is 16 raised to 1 over 2. 16 raised to 1 over 2, which is equal to, since it's 2, the denominator of the fractional index or fractional power is 2. That will be the second root of 16. But like I said, if it is 2, you don't write it. It's from 3 and above that you're going to write the figure here. So 22 over figure 2, 27 raised to 1 over 3. The denominator is 3, so it's going to be third root of 27, which is the base. 4 is the fourth root of 10,000. So number 7, x raised to b over e. For this part, the difference between this and this is that here the numerator is 1 and here the numerator is higher than 1. So in cases where the base is raised to a fractional power, but the numerator of the fractional power is greater than 1, this is what you are going to get. So the denominator of the fractional power will form the root of the base. Then it will be multiplied or it will be raised to the numerator. So a root x, or a root x, which is the a root, the 8th root of x, the 8th root of x multiplied raised to power b. So if okay, so examples of simple application. So 4 raised to 3 over 2 this is known as the second root of 4, which we call root 4 commonly. The second root of 4 raised to power 3. So the numerator would be the power that the second root of 4 would be raised to. And 125 raised to 2 over 3. That will now give us the third root of 125 raised to the numerator, which is power 2. And then 81 raised to 3 over 4 is equal to the fourth root. The denominator will give us the fourth root of the base multiplied by the numerator, which in this case is the fourth root of 81 raised to 3. So you can see that in this summary, we did not simplify, we don't get to the final answers. This is just for illustration, and subsequently so we take examples and more exercises. We're going to see how these laws are applied and what the final answers will become.